So we got another illustration, and this is really interesting, so you should pay more attention because it is locus based. Okay, you can expect this kind of questions in advance mainly. So let's do it. Let rs be the diameter of a circle this. So this circle is very unique. You know that this is a circle whose center is at origin, है ना, and the radius is 1 only. Okay, now be super slow. So they are talking about rs, so pay focus on rs, where s is a point 1 comma 0. So this could be what? S 1 comma 0. They were talking about rs. Rs was what? Diameter. So this could be r. So if s is 1 comma 0, r would be what? Minus 1 comma 0. If you are not comfortable, go with midpoint because this center will be 0 comma 0. Okay, so this center will behave as midpoint of r and s. Comfortable? Now let's proceed with the question. Let p be a variable point other than r and s on the circle. So you have to imagine a variable point. Variable point means what? The point can be anywhere. Okay, so you have to imagine a point on the curve. You know that wherever there is requirement of imagining a point on the curve, we used to imagine it in exactly parametric form. So the parametric form is what? You know, it is cos square theta, it is sin square theta, and r is 1 only. So it is cos theta comma sin theta. Correct? So you got your point P. Done? Now, and tangent to the circle at S. So at S you have to drop a tangent. Look at this. I'll connect that tangent. Okay, be careful. So tangent at S, correct? So look at this. Don't you think it will be a perpendicular line? Correct na? So if it is perpendicular, so a line perpendicular on x-axis will be parallel to y. And can you tell me the equation of this line? This line is what? X equals to 0. So this line would be what? X equals to 1, because it is passing through 1, means on this line everywhere we will have x coordinate as 1 only. So you have already dropped down tangent to S, and you got equation of tangent to S as x equals to 1. I hope till this part you are okay. And also if you are not comfortable now, put t equals to 0 on this curve. You will get your same result. Okay, because you know that 1 comma 0 is lying on the curve. Comfortable? Now let p be the variable point other than r and s on the circle and tangent to the circle s and p. So at p also you have to drop down tangent. Correct? So at p tangent, so tangent at p would be what? T equals to 0, transformation. So it is x, x1 plus y, y1, because it is x square and y square, no? So you got your tangent at p. Okay, tangent at s. I hope till this part you guys are okay. Now meet at the point Q. So these two tangents are meeting at point Q. So we have to find out point Q. So you know that point Q is common to both the tangents. So if we will solve both the lines, we will get point Q. Also you know that everywhere s x coordinate would be 1. So at this point also x coordinate would be 1. So how we will find y coordinate? So for y coordinate we will put in this equation, means in this equation we will put x equals to 1. So it will become 1 minus cos theta upon sin theta. Is that okay? So you got your intersection point. Comfortable, na? Now let's proceed. The normal to the circle at P. Now you are talking about normal to the circle at P. Intersect the line. Okay, wait. We will find normal to the circle P. So normal P. You know that normal of a circle will always pass through circle, will in circle normal will pass through center, है ना? So let's find out the equation. P we already know. Okay, now look at this. So can I write y minus 0 x minus 0? I am using this point and I am assuming a single point x comma y on the line. So I am applying slope equal to slope. Okay, is equal to slope of this thing. You know point P. So it was what? Y2 minus y1 sin theta minus 0 by x2 minus x1 cos theta minus 0. Correct? Now can I say it is y cos theta equals x sin theta? So you got your equation of normal. Okay, I hope equation of normal is perfectly fine for you guys. Okay, also if you are not comfortable, you can go with y equals x times tan theta, so that you can have only one trigonometric ratio. Okay, now look at this. The normal to the circle at P intersect the line drawn through Q. So through Q you have to draw a line which is parallel to RS. So parallel to RS. So look at this. This was your RS, है ना? So parallel to this line you have to drop down a line. Okay. So don't you think that here, if it is parallel to this line, again it will be perpendicular, है ना? And here y coordinate will remain the same. So y equal to this would be what? 1 minus cos theta upon sin theta, है ना? Okay, intersect the line through Q parallel to RS at E. So this is point E, and you have to find out locus of E only. Then the locus of E passes through the points, point or points. So you have to find out locus of E. So locus of E is who? It is point of intersection of this part. Correct? So can I say that E is the point of intersection of this line and the normal? So what is normal? Normal is y equals to x tan theta, and this line is what? Y equals 1 minus cos theta upon sin theta. So we have to solve these two lines. We will get the locus of E, point of intersection. I hope it is clear. Pakka na? Now look at this. If you will observe this thing na, if you want to simplify, okay, you have to remove locus. Means what? You have to find out equation of something, and that something should not contain any entity which you have asked to come. Correct? In this part, if you'll observe, you have asked theta to come. Correct or wrong? It was your assumption. So you have to write down locus of E in such a way so that you cannot have the theta component. So if you want to solve these two things, you cannot compare both way. Okay, this means how we will solve. Look at this, we have problem with theta, and if you will observe theta, theta is associated with trigonometric thing, है ना? So what I want to do, I want, and in trigonometry also we have three trigonometric ratio. We have sine, cos and tan. It's ugly, correct na? So we want to convert every trigonometric ratio in the same form. So do you remember 1 minus cos 2 theta? What is 1 minus cos 2 theta? Look at this. Cos 2 theta is 2 cos square theta minus 1, and 1 minus 2 sine square theta. So I am talking about 1 minus cos 2 theta. So this has to go to that side, means it would become what? 2 sine square theta 1 minus cos. If you want 1 minus 2 cos, okay. If you want plus, then this formula will be used. If you want minus, this formula will be used. Okay, so can I write 2 sine square theta by 2 half? It will become, no, 2 theta 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 half. Okay, now can you write down this sine theta as something else? Yes, 2 sine theta by 2 cos theta by 2. Now this thing and this thing will be neutralized, this thing and this thing will be neutralized, and we will be left with sine theta by 2 upon cos theta by 2, which is tan theta by 2. So you have y as tan theta by 2. So can I write this equation in terms of tan theta by 2? So can I assume this thing to be tan 2 theta? So it will become what? 2 tan theta by 2 upon 1 minus tan square theta by 2. Correct or wrong? Now let's rewrite that. Let's just update this equation. So 2x, you know, tan theta by 2 is what? Y. So can I write y upon 1 minus y square? Okay, can I neutralize this with this? So we will be left with 1 minus y square is equal to 2x. So this is the locus of E. So this was the required thing for this question. I hope this question is clear now. If you are finding any difficulty, please put comment on the comment box. I'll try to resolve that thing as soon as possible. Also, if you find any interesting questions, please put that in comment box. We will take those questions in upcoming videos. Okay.